Hello. So I will start, I guess. So this is 2014 Amy 2 problem 5. So real numbers R and S are roots of P of X is equal to X cubed plus AX plus B, and R plus 4 and S minus 3 are roots of Q of X is equal to X cubed plus AX plus B plus 240. Find the sum of all possible values of the absolute value of B. So here we notice that the x squared coefficients of both P of X and Q of X are equal to 0. So this probably tells us that we should use Vieta's formula. And since R and S are roots of P of X, that means that since x0 has a coefficient of 0, negative R minus S should also be a root of P of X, since negative R minus S plus R plus S is equal to 0. And similarly, since Q of X has roots R plus 4 and S minus 3, the remaining root should be negative R minus S minus 1. And next, the coefficient in P of X and Q of X, since they're like both equal to A, that means that they are equal. So from here we can write an equation. So we would have that RS minus plus negative R minus S times R plus negative R minus S times S is equal to RS minus R squared minus SR minus RS minus S squared is equal to minus R squared minus S squared minus RS. And for Q of X, we would have R plus 4 times S minus 3 plus R plus 4 times minus R minus S minus 1 plus S minus 3 times minus R minus S plus 1 minus 1. And this is equal to RS plus 4S minus 3R minus 12. And then this part here is just R plus 4 and S minus 3 combined to R plus S minus 1. So we're essentially subtracting R plus S plus 1 squared. And this is equal to RS plus 4S minus 3R minus 12 minus R squared minus S squared minus 1 minus 2RS minus 2R minus 2S. And this is equal to minus R squared minus S squared minus RS minus 5R plus 2S minus 13. Okay. And we know that this is equal to minus R squared minus S squared minus RS. So we can actually cancel out this part, and we are left with 5R plus 13 is equal to 2S, or S is equal to half times 5R plus 13. And this is great because now we have S in terms of R, and so we can finally use the last condition, which is that the constant of P of X is 240 less than the constant of Q of X. So we have that since the roots. So for P of X, we have RS okay, so for P of X, so it should be negative times negative of RS times negative R minus S which is equal to rs times r plus s, which should equal to r 5r plus 13, 7 halves r plus 13 halves. And this is equal to 1/4 of 5r squared plus 13r times 7r plus 13. And for 240 plus b, which is the constant of q of x, this should equal to negative r plus 4 times s minus 3 times negative r minus s minus 1. And this is equal to r plus 4 times s minus 3 times r plus s plus 1. We can replace our value of s. So we have r plus 4 times 5 halves r plus 4 halves times 7 halves r plus 15 halves. This is equal to 1/4 of r plus 4. Right? So from here, we can expand the parentheses. And so actually, first what we're going to do is we're going to say that, well, actually, we're going to say 1/4 times r plus 4 times 5r plus 4, 7r plus 15, minus 1/4 times 5r squared plus 13r times 7r plus 13 should equal to 240. And right off the bat, we can cancel off our 1/4, and so this is 960. And here, we know that this is 5r squared plus 24r plus 16. And when we multiply this by 7r plus 15, we have 35r squared plus 160r squared plus 112r plus 75r squared plus 240r, right, sorry, 20, that should be 360r. And so this is our left-hand side, and sorry, this should be cubed. And over here, we have 35. Sorry, my okay. Anyways, so 35r cubed plus 65r squared plus 91r squared plus 169r. And when we subtract these two equations, note that the 35r cubes cancel, and 65 plus 91 is 156r squared. Like together is 156r squared. So if we take this away from 168, we're left with only 14r squared. And 112, when we take away 169, is just minus 57r plus 75r squared. Oh, I did not see that. Okay. Plus 240 is equal to 960. And we can also just subtract 240 on both sides. And so here we have 14r squared plus 75r squared is 89r squared. That seems okay. Anyways, so 89r squared and then plus 303r is equal to 7. Yeah, I did something wrong. So the roots of rs so the roots, okay, so the roots are r plus 4, s minus 3, and minus r minus s minus 1. So then we have r plus 4, and s minus 3 should be, s minus 3 should be 5r over 2. Plus, oh, okay, so this should be at 7. And minus r minus s minus 1. So that's minus r minus r minus 1/2 of 5r plus 13. Minus 1, and that's equal to minus 7/2 r minus 15/2. So yes. Okay. I think it should be right now. So, okay. Let's rewrite the equation. R plus 4 times 5r plus 7 times 7r plus 15 minus 5r squared plus 13r. Okay. 5r squared plus 13r times 7r 5r squared plus 27r plus 28. I'm multiplying this by 7r plus 15. This is equal to 35r cubed plus 189r plus 35r cubed plus 7 times 27, which is 189r squared plus 75r squared plus 196r plus 15 times 27 plus 15 times 28, so that's 420. So basically, once we have this, we're using this minus this. So this is 35r cubed plus 91r squared plus 65r squared plus 169r. And so when we subtract them, the 189 minus 91 turns into 98r squared. 91 plus 65, so that's 156. And 189 minus 156. Ooh, okay, so that's 33r squared plus 75r squared plus 405r plus 196 minus 169 should be 27r plus 420 is equal to 960. And so we cancel this and we get 540 here, and then here 33, this is 108r squared plus 432r is equal to 540, which if we divide both sides by 108, we get the r squared plus 4r is equal to 5. So that means that r is either equal to 1 or r is equal to -5. And so once we have this, from here, since we know that the formula for S, see if we can find it. S here is equal to 5r plus 13 over 2. So S is equal to 9 and S is equal to -6. And so that means that we're looking for the value of B. So B is the product of the roots of P of X, which is just B. So that means that the third root would be -10, right? And over here, third root would be 11. So here R times S times the third root would be 330. And here it would be 1 times 9 times -10. So this will give us the absolute value of the 90. So we combine these two and we got 420 as our final answer. So the answer to this question is 420. Okay, next question. Actually, I'll just move it. So for this question, for some integer m, the polynomial x cubed minus 1011x plus m has the integer roots a, b, and c. Find the absolute value of a plus the absolute value of b plus the absolute value of c. So first, what we can do is just first use Vietas because that's what we can do, right? So a plus b plus c is equal to 0, and ab plus bc plus ac is -2011. So from here, we get that c is equal to minus a minus b, which we can just replace in this equation. So we get that ab plus a plus b times c, which should be -a minus b, is equal to minus 2011. So ab plus 2011 is equal to a plus b squared. And we also know that a and b are integers. So we could just try value for a plus b. So the smallest square greater than 2011 is 2025, which is just 45 squared. And so if it's 2025, when we subtract 2011, we get 14. And for this, we have 5 and 9. Wait, no, sorry. I'm stupid. So there's no integers that have a sum of 45 and a product of 14. So this doesn't work. If it's 46 squared, then we have that a Okay, sorry. It's just sinking. So have a plus b is equal to 46. So 46 squared 46 squared is equal to 2116, I think. If I did that right. Yeah, 2116. And 2116 minus 1011 is equal to 105. And so we need to find two integers that have a product of 105 and a sum of two integers that have a sum of 46 and a product of 105. And so that doesn't work, right? Because yeah. So next we have 47. 47 squared is 2209. Yeah, 2209. And 2209 minus 2011 is equal to 198. And so we basically need to find two integers that have a product of 198 and sum to 47. So let's see. 998 is equal to 99 times 2, right? So that's 11 times 18. Nope, that doesn't have the same sum. So what's the smallest factor greater than that? 14, 15, 2. But there's no factors like, wait, you can do like 9 times 22. That's still too small. You can do 6 times 33, still too small. 4, there's no, and then you have 3 times 66, which is too big. So this doesn't work. If we have 48, on the other hand, 48 squared is 204, and we subtract 2011. So we get 293 is the product. So the factorization of 293 is prime. I think it's not divisible by 17, is it? No, it's not divisible by 17. So this is prime. So this automatically does not work. Next, we try 49. So 49 times 49. We know that this is just 241. So basically we have 241 minus 2011. And this is 390. So we need to find two numbers that multiply to 49 and sum to 390 and sum to 49. Well, that's just 39 and 10. So we actually found our A and B is just 39 and 10. So that means that the last root must be the negative of that, negative A minus B. So that means that we have 10, 39, and minus 49. So when you sum the absolute values, you just get 98. Okay, I think we might have time for another one. Okay. So let's read it. In triangle ABC has a right angle at C0. Its side lengths are pairwise relatively prime positive integers, and the perimeter is P. Let C1 be the foot of the altitude to AB, and for n is greater than or equal to 2, Cn be the foot of Cn minus 2b in triangle Cn minus 2, Cn minus b. The sum of that is equal to 6 times p. Find the value of p. Okay, so first we can like draw it out, right? So C1 is this foot, and then C2 is here, right? C3 is here. This continues. So we basically need to find the value of each of these segments. And to do this, first we can denote this as A, B, and C, right? So if the values are of A, B, and of triangle ABC0 is A, B, and C, then we know that A squared plus B squared is equal to C squared. Furthermore, we know that C0, C1 is equal to AB over C. Next, since C0, C1 is AB over C, then that means that since we know that triangle BC1, C0 is similar to triangle BC0A, that means that C1, C0 over AC0 should equal to BC0 over AB. And BC0 over AB is equal to A over C, while C1, C0 over AC0, this is just B. So C1, C0, or sorry, yeah, okay. Wait. I wrote the wrong relationship. I'm sorry. So that means that we can calculate C1, C2, and C1, C2, sorry, it should be B, C2, C1, let's say. So,
Looking, really?
sorry?
RS 個 project 今天晚上要對，但我 prep 已經做完了，我就把它聽完。
Does anyone have a question?
No, it's all beautiful guy.
哦，對。
Okay. Anyways. Okay, so okay. So okay, so we know since let's say that triangle BC0 C1 is similar to triangle BAC0, which means that BC1 over C0 C1 is equal to C0 C1 over AC1. And this is also equal to BC0 over AC0. And BC0 over AC0 is A over B. And so since we know that C0 C1 is just equal to AB over C, that means that BC1 over here is just equal to A squared over C. So then we can find the value of C1, C2 is equal to B over C times A squared over C, which would equal to A squared B over C squared. And next, since we know that this, we notice that actually there was an easier way to find this if we just instead had realized that the ratio of C1 C2 to C0 C1 is just ratio of like the sign lengths of C0 C1 B to A C0 B. So the ratio of their hypotenuses is A to C, which means that the ratio of their heights is A to C. So this is actually just equal to A over C times C0 C1. Similarly, we can say that C2 C3 is equal to A over C of C1 C2. So this is actually a geometric sequence. So we know that the sum here that's equal to 6p is just A over C times 1 over 1 minus A over C. And this is equal to 6 times P. And we know that P is equal to A times P plus C. So we simplify the left hand side. And we get that AB is equal to 6 times A plus B plus C times C minus A. And A plus B plus C is equal to 6P. Oh, yes, that's so, okay. Okay, we can, from here, we know that, so we have 6 times P times C minus A is equal to A times B. And so we can basically calculate the value of A, B, and C. So, well, we can't really calculate it in this case, but we can try to find a triple that works. So, so I guess, how should we do this? So we just can do a bit of expanding, and then we know the right hand side is divisible by 6, so the left hand side should also be divisible by 6. And we so far haven't really used A squared plus B squared is equal to C squared. So, oh, okay, this is equal to 6B squared. So 7A is equal to 6C plus 6B. Or 7A is equal to 6 times C plus B. Wait, I guess we could say 7A plus 6B is equal to 6C, so 49A squared plus 36B squared minus 84B is equal to 36A squared plus 36B squared. We cancel this, cancel that, make this 13A squared, cancel this, move this term onto the other side. So we have 13A is equal to 84B. And from here, we can just see that A is 84, B is 13. And what's square root of 84 squared plus 13 squared? 2256 plus 169, which is 5242, I believe. Something wrong. Wait, what am I doing? This is the 6-7. Okay. So this is 6507. 7056 plus 169. This is okay. This makes more sense. So 7225. So this is equal to 85 because 7225 square root is 85, which means that the perimeter of the triangle is just 84 plus 13 plus 85, which would equal to 84 plus 98, which is equal to 182. So that's the answer to the question. And I think that's it. So